This is Oral Physics 505 for October, November 2025, paper 1-2. These are the grade thresholds to score in A, B, or C. Question 1 suggests to show the reading on the micrometer. So the method is to find the largest reading on the main scale, which is 5, 6, 7, and then 7.5. So it's pretty obvious that it's going to be around 7.5. So this is not possible. This is also not possible. And since the main reading is 7.5, the circular scale reading gets added into this. So very quickly, we could have figured out that this is going to be option B. But let's look at the procedure. The line that coincides with the main scale is 25. Multiply this with 0.01. We get 0.25, which gets added into this number for the main scale, which will be 7.75 millimeters. So answer is B. Either you calculate this or save time by guessing it. Question number 2. It states that these are the vectors for the resultant force. The resultant force will be at the center somewhere. We can find this by using Pythagoras theorem. So it will be simply 2 squared plus 1.5 whole squared. The resultant will be equal to square root of this problem, which is going to be R equals to 2.5 newtons. This is option B. Question 3 states, defines acceleration. That will be simply a change in velocity or rate of change of velocity divided by time taken. Speed is incorrect. Distance, no, it's incorrect. And distance is incorrect. It has to be velocity divided by time, as A is equal to V minus U divided by T. Next question, question 4. He says the acceleration free fall on the moon is 1/6 of the acceleration of the Earth. What is the approximate weight of 1 kg mass on the moon? So you see, we want to find the weight, which is going to be W equals to mg. So this is simply 1 kg into g of Earth, which is 9.81 divided by 1/6. So divide this with 6. Our answer comes out as 1.635 newtons, which is option B. Question 5 is about ultrasound and deep sea marine time-seeking sonar, something like this. The time interval is 0.52 seconds transmitting and detecting, which means that if this is where the ship is and if this is where that place is, the time to go and come back, both times are 0.52 combined. So since we are interested in the depth, we only have to take time for one side. We have two choices. Either we can divide the time by 2 or we can take the distance as 2. So simply speed equals to d plus d divided by t becomes 2d divided by t. T is given to us, and it's simply a matter of placing values, which is 1500 equals 2d divided by 0.52. So our answer comes out as 390 meters. Question 6, definition of mass and measuring instrument is very straightforward. It's not a force, it's actually quantity of matter or amount of matter. Force meter is used for weight, which is newtons. Electronic balance is a better choice for part C. Question 7 is about density, measuring cylinder scale. This is approximately 35 and this is approximately 59. What are the correct values of the volumes of water and rock? So the volume of water before the rock was placed is 35, and the volume of rock is simply 59 minus 35, which comes out as 24. This is going to be option C to be the right answer. Question 8, which quantities can be changed by a force? This used to be the first question, but let's see. So mass, no, mass cannot be changed, so no point checking the rest of the option. No. Shape, yes. Velocity, yes. Volume, yes, it can be compressed in case of a gas. So it's option D. Question 9 is interesting. You see the graph is about resultant force, which means that whatever object it was acting on, this could be a forward force. Let's call this F, which is pulling it together, is pulling it to the left, to the right, sorry. And there is some drag forces. For example, let's call this friction drag or simple friction forces. So by the combination of these two forces, there is going to be a resultant force. Let's call this FR. FR is equal to the forward force by the engine minus all the drag components, let's sum them together as D, equals to MA. So the resultant force is decreasing. We don't know why this is happening, but we do know is that it is decreasing. It is quite possible that the drag is not changing and the engine force is decreasing, leading to an ultimate decrease of this value to 0. Or the force is not changing of the engine, but the drag is increasing with the passage of time, ultimately giving us the answer as 0. As we can see that at time t0 it becomes 0. So resultant force is today proportional to acceleration because mass is constant. So the resultant force is decreasing, acceleration should also be decreasing. And all of this conclusion has been from the topic of dynamics. Now he wants us to choose a speed-time graph that is appropriate for the object. For a speed-time graph, we understand that the gradient of this graph is actually equal to acceleration. This is a visual indication. So I want something the resultant force decreases with the passage of time. So the acceleration also decreases with the passage of time. That's the indicator. So let's eliminate options that should not be possible. Option D is impossible. They will not follow the same curve because one of them gives acceleration, the other one is speed. They're two entirely different quantities. Option C could have been the answer, but the fact that it is a linear relationship suggests that the acceleration was always constant. If the acceleration was constant, then the resultant force was also constant, which is not the case because the resultant force is decreasing with the passage of time. So it's not possible. That would be option C. Option B would have been the right answer if the graph was about acceleration. If this was acceleration, then this graph makes sense because with the passage of time, the acceleration is also decreasing non-linearly, right? It could have made sense. So let's go to option A. In the early days, the gradient is very high because the resultant force is really high. So the acceleration is really high. And eventually, at time t0, when the resultant force becomes 0, Fr becomes 0, acceleration becomes 0. So if the acceleration is 0, then visually speaking, the gradient should also become 0. The best graph that represents this behavior is option A. Question number 10. He says, which object rests on the table? Okay, find the length of arrows, free body diagram, magnitude. We understand that they represent the length, represents the magnitude of the forces. Which diagram shows the free body diagram of the object? Okay. It rests on a table. So contact force is incorrect in the position, weight is incorrect. But if this is the table, this is the object, weight is supposed to be downwards and normal reaction of contact force is supposed to be upwards. And they're supposed to be equal in magnitude because it's resting on the table. So this is wrong because of the incorrect length. This is wrong due to incorrect positions and length. The best answer is option D. Weight and normal reaction are equal in magnitude, which is why it's resting on the table surface. Question number 11. Load extension graph. He says, what does the point X mean? It's the limit of proportionality. It's a fact-based question. It is repeated many, many times. Sometimes he's going to ask you about the limit of proportionality in the question and then ask you to pick a point, let's say A, B, C, and D. So it's generally before the curve, the point that is limit of proportionality. Question number 12, a very common previously repeated question. He says the direction of the resultant force, which is going to be option B. This is due to the centripetal force provided by the friction in this case for a vehicle. Question 13 requires a bit of calculation. So everything is given to you. The question is about on which part of the plank the object should be placed so that it stays in equilibrium. So let's find out the moment by both sides. So due to 140, it's going to be anti-clockwise. The distance is 1.2. So this moment is 140 multiplied by 1.2. This gives me 188 Newton meters. If you go for the clockwise moment, which is due to y in this direction, this will be simply 220 force multiplied by its perpendicular distance from the pivot, 0.55. This comes out as 121 Newton meters. As we can see that the anti-clockwise moment is higher than the clockwise moment, let's see what's the deficit. So the delta moment is simply 188 minus 121. This comes out as 47 Newton meters of torque, or of moment that is missing, right? Yeah. So now we have to add this moment either by placing here or here. So it has to be on the right side. So 47 Newton meters is missing from the clockwise side. How much force should we exert and at what place? So it's mentioned that there is a box, there is a part that is going to be placed here. If you notice, there is a third object of 110 placed somewhere along the plank. So force is 110 multiplied by distance, we don't know. So distance comes out as 0.43 meters from the pivot. So and it has to be on this side, right, to favor the clockwise movement sign because it's lacking. And since this is 0.43 meters, that means it's from the center to this point, 0.43 meters. So it definitely exists in this region, region C. 14, which statement about center of gravity is correct? This is based on previous knowledge and facts. Center of gravity is same height, okay, less stable with bigger base. Same height are more stable with bigger base. Yes, this is false. Objects with higher center of gravity and smaller base, this is completely false. This is anti-stability. With identical bases are more stable when the center of gravity is higher. No, it's more stable if the bases are identical where they stand. Then it does stands to reason. The benefit is when the center of gravity as low as possible. So the best answer in this situation is option B. Question 15. Energy stored in batteries, fuel, and chemical. Which type of energy? This is chemical, and if we write down completely, this is chemical potential energy. Option A. 16 has proven to be a bit more difficult by the students, and I get this question a lot. You see, he's made this in bold, and it's all about English comprehension that's causing you trouble. You see, the empty mass rocket was m, and its own velocity was v. So the initial energy or kinetic energy of the rocket is half capital mv squared. Under the new situation or new circumstances, the present day conditions or new kinetic energy is simply half. The mass is still the same because it's still the rocket multiplied by 2v. The velocity has increased as 2v whole squared. This comes out as half m v squared multiplied by 4. So based on the original kinetic energy and the current kinetic energy, there is a difference of a factor of 4. And since it's only about the rocket, we're not interested in the fuel. So I've talked everything about the rocket only. So it increases by a factor of 4. 17 is about previous knowledge again. Efficiency is supposed to be, it needs to have same units. So energy, 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 and all the options is fine. Then it has to be output over input. So this is wrong. This is also wrong. This seems to be fine. This seems to be fine. Now, we have to decide between useful and total. So efficiency is all about useful energy output, what the machine was actually designed to do for me. Did it do that or did it not? If we talk about the total energy output, then let's look at a Sankey diagram. So this is the useful output and this is the wasted output. According to law of conservation of energy, whatever energy or power I invest into the machine, let's say this is 500 watts for the sake of example, and the useful output is, let's say, 350 watts, then the wasted output is 150 watts. These are all outputs. If I add them together, it again becomes the total input. So this answer will always be 100%. It's not right. It's always supposed to be useful divided by the total input, right? Okay. Question 18 is a lift system, previously done many times. So a bucket or a lift has to be lifted up to a single point in a certain time frame t. So the energy investment, if you want to find power, is simply gravitational potential energy invested over time. This is going to be mgh divided by t. But let's look at the variables given to us in the question. So vertical distance d, so in place of h we need d, and time is same and p is required. So it's going to be simple mgd based on new variables. This is going to be option B. This is a repeated question. Please keep this in mind. Question number 19 suggests which one of them has a pressure of 1 Pascal. So pressure is equal to force divided by area, right? So let's check this in all the cases. Force has to be in newtons and area has to be in meters squares. Only then we can call this pascals. So kg, no, not even bother testing this. 1 Newton, yes. 1 Newton, yes. 1 centimeter squared, no. 1 meter square, yes. So the correct answer will be option D because it's in standard units of newtons and meter square. So 1 divided by 1 gives me 1 pascals. Question number 20 requires a bit of calculation. He says different liquids poured in different containers. The bases are different. Which container is the force exerted by the liquid on the bottom of the container the greatest? So the general formula is pressure is equal to force over area. Since we're interested in the force, area goes there. This is going to become force equals to pressure multiplied by area. But I need to find the pressure, which is going to be rho g h. So density as rho is given, g is 9.8, h is given in centimeters. The density is also in centimeters. We don't need to convert the height into the usual meters. So if I want to calculate the pressure, that is rho GH in this column for all the situations, this will simply be 1.3 multiplied by 9.8 multiplied by 50. So the answer I'm getting here is 637 pascals. This will be 627 pascals. This will be 588 pascals. This is 661 pascals. And rightly so, I shouldn't be writing pascals at this stage because it has to be in centimeters, it has to be in kg. But anyways, for the sake of example, let's say that they are in the standard units. I want to find the force. Force is supposed to be pressure multiplied by area. Now, I have all the pressures, so let's find the force by multiplying these numbers with the cross-sectional areas of the bases. So 637 multiplied by 10, then 627 multiplied by 20, 588 by 40, and 667 by 50. So if I make a column for force, this again comes out as a few options. Let's say the first column comes out as 6370 newtons. This one comes out as 1240 newtons. This one is 23520 newtons. This one is 33050 newtons. And again, please be advised, I'm aware that I haven't converted these into standard format, so I shouldn't be calling them newtons. But since the unit conversion actually travels along, I'm going to save time in the MCQs, and I'm going to just rely on the fact that centimeter, even if carried forward, still does not change the fact that the answer is going to be right. The option D is the right answer for the greatest pressure at the base. Question number 21. Student properties of matter, partially completed book. It's random, moving freely. Only a freely moving thing is a gas. So it should be a gas. And for gases, the forces between the particle are weakest, and expansion when heated is the greatest. Because there are no bonds between them to hold them together, it's very easy to pull them apart from one another. It's going to be option B. Question number 22 says air is trapped in a liquid. The pressure when it's at 50 inside the gas container is 1.0 into 10 raised to the power 5 pascals. So it looks like that we are going to require P1 V1 equals to P2 V2 as the formula. So the initial pressure is this, but is this volume? No, this is not. This is actually the height of a cylinder, which is circular in dimensions. If I wanted to calculate the surface area, which is going to be pi r square, the volume would become pi r square h, which is 50 multiplied. So if we do this properly, conceptually, this should be 1 into 10 raised to the power 5. The original volume will be pi r squared multiplied by 50. 50 is still converted into meters. But we're skipping that because on the right-hand side, we're going to get the same thing. Equals to P2 V2 condition, in which we want to find the new pressure. We don't know. So P multiplied by circular surface area, pi r square, multiplied by 45 millimeters. Now you notice that the millimeters will be cancelled from both sides with the 50 and with this. And pi r squared gets cancelled with pi r square. So we are left with an equation which looks like 1 into 10 raised to the power 5 into 50 equals P into 45. So the new pressure comes out as 1.1 into 10 raised to the power 5. But it's going to be option C. Question 23 is about memory again. You want to convert gas into liquid, it's going to be condensation. And you want to convert, and if you want to look at the arrows, solid to liquid is melting. It's going to be option D. Be careful. 24, energy can be transferred by thermal radiation. 4 surfaces are given. Which one is the fastest rate? So it has to be either black and it has to be dull. Your shiny surfaces are good reflectors and bad absorbers. So we want the fastest rate of thermal radiation. So it will only be black and dull or rough texture. 25 says, again, a key concept tested here is mentioned in the syllabus. It says which one releases the radiation with the greatest rate. They have identical surface textures, they have identical surface colors. So which one will release the radiation greatest? So higher temperature causes more radiation and more surface area releases more radiation or helps release more radiation. So it's going to be option D. And please remember this is a repeated question and a key concept in physics, conduction, convection, and radiation. 26. Material are shown, speed of sound is shown, wavelength is shown. Which waves are ultrasound? So we're going to use V equals to F lambda to find the frequency of all of these, which is, for the first one, I'm going to show you how to do this. So this is going to be 340 equals to frequency multiplied by 0.19. So find the frequency for all the options. I'm going to give you the final answer so you can test this on yourself on your question. So this is going to be 1790 hertz. The second option is 30,000 hertz, 17,391 hertz, and this is 21,612 hertz. Now, ultrasound is when it is above 20,000, specifically above 20,000. So this qualifies as above 20,000, and this qualifies as above 20,000. This doesn't. This also doesn't. So student number, or wave number 2 and wave number 4 is going to be option C. Question 27, it says light passes refractive index, material I, and it's very simple. Refractive index is equal to sine I over sine of R. Rearrange this to bring n over here. It's going to become option D. Question 28, this has been repeated many times in the past papers. It's exactly the same question. It says reflected by a plane mirror. So the change in medium stuff will not happen. And with B, the problem is that the normal has to make an angle of 90 degrees with the surface, but the angle of incidence and angle of reflection for a plane mirror is supposed to remain the same. It's going to be option D. Question number 29, which object is placed in front of the plane mirror? Which statement about the is correct? Now, it's not real, it's virtual, and it's not smaller, it's the same size. As when you look at yourself in the mirror, it's exactly the same thing. This is going to be option D. 30, it says the angle of incidence are different. What is the possible critical angle for the light in this case? You see, when the light goes from glass to air, it's bending away from the normal, and we can see total internal reflection happening between stage 2 and stage 3. And when this has happened entirely, this will also be 50 because it is total internal reflection. Angle of incidence and reflection will be the same. Here, it's 40 and it's downright very close to being 90 degrees. So it should be between 40 and 50. The critical angle should be between 40 and 50. So it's not 50, it's not 30, it should be 45, cannot be 60, because it has already happened. If we increase the angle and introduce this at 60, the angle of refraction will also be 60. And besides, the reflection part has already happened. So we're looking for a critical angle where it will become 90. Okay, so it's going to be option C. Question number 31, he says, student goes investigation forth in lenses. Okay, fine. Now, this is a new question in terms of how to check the magnification. There are two formulas. So linear magnification was height of image, how high it is, divided by height of object. A similar formula would actually come around this. But for example, if this is what the object is, for example, the height is HO, and for example, this is the image, this total height will be HI. This ratio also corresponds to a position or to another idea that is equally workable. So the distance of the object, let's call this distance object, and the distance of the image, let's call this distance I, are also proportional. They're also equal to the linear magnification. So you can check with heights or you check with distances, they're going to be the same. So distance, this time there will be distance of image divided by distance of object, which will become, it's already given. The image and object are given. What we can do is simply divide these two numbers together throughout the table for a quick succession. So linear magnification, in each case, this first one will be 3.5 divided by 0.8, comes out as 4.375. This next one is 7.83. The next one is 6.86. The last one is 5.78 using this formula. So the greatest magnification is produced in option B. 32 is a good question from the past papers. So W is south, south, and X is given to you as north, south. And it's very befitting in this sense because north, south seems fine. If this is south, then this should be north, and if this is south, this should be north. So the correct answer will be option B. And the reason we're saying this is because if you look at a magnet, one side is south, one side is north. It's understood at this stage. Question number 33. This is interesting. He says a cardboard tube has wire P and Q connected to the ends. Fine. The potential difference is 9 and current is 0.75. So if you want to find the resistance, let's first apply V equals to IR. This is 9 volts available, current is 0.75. How much should be the resistance be? It comes out as 12 ohms. Okay, fine. So let's work with 12 ohms. Now let's see, he says what could be between P and Q. 0.75 and 6 ohms in parallel. You see, if in a parallel combination, whoever is the smallest element actually decides what is going to be the final resistance. So if this was true, then the total resistance or final resistance would be smaller even than 0.75. This is wrong. 0.75 resistor in series, if they are in series, they will be added together. So this becomes 6.75, which is again wrong because we're looking for 12. 20 and 30 connected in parallel, this seems to be the right answer, but let's see if that's the case. Let's try this. If they are in parallel, then I have a method for you in place. We do understand that we deal with the fraction method, which is going to be 1 divided by 20, then simply plus, again use the fraction, 1 divided by 30, and then on the outside, take the reciprocal because we forget this at the end. It will automatically calculate this for you for 12. This means that this option looks plausible. 20 in series. If they are in series, they get added together at 50 ohms. So the correct answer is going to be option C. 34. We're going to draw two extremes for this situation because it can go from 0 to 2R. What if that the fixed resistor does not change and the variable resistor has 0 ohms today, and we have a cell? When there is no resistance offered, if there was a voltmeter connected, it will give you 0 volt when it's 0. So it definitely starts from 0 in all the cases. That's not the debate. The problem is that if this goes to 2R, what do we do then? So let's draw the circuit when it goes to 2R. This is R, this is 2R, and now we have the battery cell and voltmeter connected between 2R. No problem. This is a series circuit. We can use potential divider rule. If I want to find the voltage of this, it will simply be R divided by the total circuit, which is R plus 2R because they're in series. This will be 3R multiplied by E. But if I want to find the voltage on the 2 ohms resistor, it will be resistance of the 2 ohms divided by the total circuit multiplied by what is being shared, which is E. E is being shared in those cases. So this comes out as 2 by 3E. So starts from 0E and should go up to 2 by 3E. The correct answer will be option C. 35. Which device works due to electromagnetic induction? Battery, no. Electromagnet, no. A motor, no. Induction is a transformer because it is expecting a change in magnetic field, eventually producing an EMF in the other coil. 36 is a bit tricky. So there is a stream of electrons which is negatively charged, and what makes them go to the top of the page, for example, like this? What type of magnetic field would this be? So first, let's try the Fleming's left-hand rule. And if we simply place, for example, this is the force that they've mentioned, particle moves upwards. This is the direction of velocity. So your second finger should be pointing this way, according to the direction of the velocity. Your thumb should be pointing upwards. And if you're using the left hand, under these circumstances, your first finger will be pointing into the page. Is pointing into the page. Now we remember that if this had been a source of alpha or simply positive charges, then this would have been my final answer. But for the electrons, we invert our answers at the end. Otherwise, placing your hand in such a compromised position is going to prove difficult. Because for the direction of velocity or current movement, for the electrons, we have to zoom the finger in the opposite direction. In that case, your second finger will be pointing left, your thumb will be pointing up, and the first finger is actually be pointing to your face. This will be pointing to your face. So this is difficult to set up, which is why I've stick to this idea that let's solve the question thinking that this is positive charge. So what? If they are negative, we will reverse the answer in the end, which we will right now. The thumb was pointing upwards in this case, matching the direction. The velocity again matching the direction. So if we fit our hand in this situation, the magnetic field is into the page. But since we're doing an electron, we invert our answer. We will say that it is out of the page. It's going to be option A. So what does that look like in 3D over here in this case? So it looks like that the stream of electrons, this is stream of electrons going. North pole was actually placed here. This is North pole. And a South pole was actually placed here. So the magnetic field was actually out of the page in that sense, and the electrons are moving this way. And then when they arrived at this location, for example, when this is the magnetic field when it's starting, they started going up towards the ceiling by experiencing electromagnetic, not electromagnetic, but magnetic force. It's going to be option A. 37. He says that thorium emits an alpha particle, no problem. The upper number will be subtracted by 4, the lower number subtracted by 2, because alpha is 4, 2. Right? Yeah, so this should be A. 223 minus 4 and 90 minus 2. No other number. This one has 88, but they actually added 4 into this, which is wrong. It's going to be option A. 38. He says radioactive source is 2 centimeters away. When he says 2 centimeters away, it means there is a very high chance that alpha will be present, because alpha's range is less than 10 centimeters. It has to be there. A sheet of paper is placed between the source. The count rate measured by count rate decreases to value greater than background, which means if it is still greater than background radiation, it means it wasn't 0, which means alpha is not the only one coming in. But one thing that's for sure is that alpha is present. Okay, fine. Now they replace with an aluminium sheet, and the count rate decreases to background radiation. It completely comes down to the value almost 0. Background radiation is generally 20, 25, 30. So it has come down to background radiation, which means that gamma is not present, because if gamma was present, it would pass through aluminium. But if aluminium is good enough to stop everything, that means gamma was not present. It's not possible. Gamma is not present. So the only option we have is either alpha or beta and no one else. So it's going to be option B. Question 39. Basic trivia questions. Earth is true. Elliptical orbit, yes. It's not a star. It does take 365 days. It rotates on its own axis in not 28 but 24 hours. It orbits, no, it doesn't orbit the moon. The moon orbits the Earth. So the correct answer is option A. Question 40. Describe redshift. So it decreases the observed wavelength of electromagnetic radiation. No, it increases. It increases the wavelength, observed wavelength, because everyone is moving away from you. So the frequency reaching you decreases. Perceived wavelength increases. It occurs planets when galaxies move. Yes, this is true. So student 2 is only correct about this. That is all for today.